In the previous lessons, you learned how the line tracking sensors worked and calculated a threshold value to allow the robot to distinguish light from dark. In this lesson, you will run the line tracking behavior on your robot using your newly calculated threshold value. The VEX line tracking kit comes as a set of 3 sensors. You may have seen other line tracking solutions that only used one sensor. Single sensor solutions work, but because they only have one reference point in their environments, those robots are actually only bouncing along the edge of the line. 3 sensors gives your robot 3 reference points, along with the ability to actually track the line and detect things like corners and intersections in the environment. The trick to getting the robot to move along the line is to assign the center sensor to stay on black and the outer 2 sensors to stay on white. More specifically, if the left sensor sees black, the robot is veering to the right of the line and needs to steer back toward the left. If the center sensor sees black, the robot is on course and should continue by moving forward. If the right sensor sees black, the robot is veering to the left and should steer back toward the right. Let's open and examine a sample program that contains this behavior. Go to File, Open Sample Program, Training Samples, Simple Line Tracking. This program was written for the SwerveBot robot model. You can use RecBot or another robot model, but remember that you may need to adjust the motor and sensor settings. Save this program in your folder before making any changes. You're probably familiar with much of the code in this sample program by now. It starts off with task main and a 2-second delay at the beginning of the program. Next, an integer variable, threshold, is declared and then initialized to the cutoff value that will be used with the line tracking sensors. Replace the value included in the sample program with the one you found in the previous lesson. Next, there's a while loop with 3 embedded if statements. The condition of the while loop is 1 == 1, checking if 1 is equal to 1. Well, 1 is and always will be equal to 1, so this creates an infinite loop that will repeat the set of embedded if statements forever. The first if statement checks if the left line tracking sensor detects a value greater than the threshold. Dark surfaces return high values to the line tracking sensor, so a value greater than the threshold means that the left sensor is seeing the line. If the left line tracking sensor is seeing the dark line, the robot needs to steer left, which it does by performing a basic swing turn to the left. The second if statement checks if the center line tracking sensor detects a value greater than the threshold, or the dark line. If that's true, the robot is on course and proceeds by moving forward. The third and final if statement checks if the right line tracking sensor detects a value greater than the threshold. If this is true, the line tracking sensor is seeing the dark line, and the robot needs to steer right, which it does by performing a basic swing turn to the right. The while loop repeats these 3 if statements very quickly, which in turn allows the robot to check the surface and adjust its motor speeds to stay on the line very quickly. This method of adjusting motor speeds based on sensor feedback may look familiar to you. It's very similar to the auto straightening code we used with the shaft encoders, but instead of adjusting the motor speeds for straight line movement, we're adjusting them for an undefined, possibly curved path. Time to try it out. Place your robot on the line, compile and download, and run. The robot tracks the line. It continuously makes adjustments based on which line tracking sensor is above the black line. Great! As a side note, if your robot is doing something more like this, or this, your threshold or your sensor setup may be configured incorrectly. Make sure you calculate the threshold value in the lighting environment the robot will be operating in, and that your robot configuration matches the motors and sensors configuration in Robot C. If, however, your robot is successfully tracking the line, you're ready to make some improvements to the behavior in the next lesson. In this lesson, you learned how the line tracking behavior works, and downloaded a sample program to the robot to try it out.